Good morning, good morning, good morning. All right, so today, hopefully first of all, yesterday's content went pretty well. Don't forget to get your submissions in for that Canvas quiz for 831. You have unlimited attempts to try and get 100%. So anything less than 100, do it again. All right, so today we're going to talk a little bit more about circumference, but before we get started, there's some things to remember. Number one, what is the difference between arc length and arc measure? Okay, so remember that we've done arc measure up until yesterday, and then we started talking about arc length. So arc measure is, let's see here, type it in here. Arc measure is the degree of the angle of the central angle that connects to the arc, the piece of arc. I'll just say the arc. Okay. Whereas arc length is the distance from one part to the other of an arc. Okay, so again, arc measure is like if I have a circle, okay, and I have this degree, and whatever this degree is from the center. Okay, this isn't working like I wanted to, but that's all right. This is the central angle, so whatever this theta is, that's the arc measure, and then this is usually a length. Okay, so centimeters, whatever it may be. It says, what ratio can we set up in order to solve for arc length? Well, we did this yesterday. So you have arc measure. So what's the central angle degree over 360? Or what is the arc length over the whole circle, which is the circumference, which is 2 times pi times radius, okay? So you can set that up and solve for whichever one you're looking for. How do we find the circumference of a circle? Well, we just said circumference is 2 times pi times the radius, or if they give you the diameter already, then you can just say it's the pi times the diameter, okay? What is the difference between arc length and circumference? And I'm just going to write this one out here instead of typing it in. Arc length is typically only a piece of the circumference. Okay, so think part to whole like we talked about yesterday. All right, so let's go through some examples here, and then pretty quick notes, and then you'll be able to actually work on the exit ticket. So, number one, it says find the following measures, the circumference of circle G. So remember that circumference is 2 times pi times the radius, but if you look here, we don't actually have the radius. This is blank, and so is that. But we do have the central angle, and we do have the arc length, right? So we're going to use this form instead of this formula. We're going to use our ratio that we had before. So we have the central angle, 110, over the total degrees in a circle that never changes. It's 360 equals the arc length, so 10.5 over the circumference. Okay. Now we typically say 2 times pi times the radius, but we don't need to because we're looking for circumference. All right, so now here's where you use Desmos. You cross multiply. Okay, so you have 110C equals 360 times 10.5, which is 3,780. Okay, divide by 110, divide by 110, and C equals 3,780 divided by 110, 34.36 repeating. Okay, so there you go. That's the circumference of circle G. Okay, part B says find the measure of YZ. Okay, so we have the arc length, we have the radius, we do not have angle theta. Okay, right, so arc measure is always on the top over 360. So that's what we're looking for. And then we have the arc length, which is 4.1. And we have the radius, which is 8.4, so we're going to plug that into our circumference, 8.4. Okay, now you can use theta, you can use x, it doesn't matter which one you use. We can use x since we're used to solving for that, that's okay. All right, so cross multiply. All right, so I have 8.4 times 2 is 16.8, so I have 16.8 pi times x equals 4.1, oops, times 360, which is 1,476. Okay, so we want to get x by itself, so we're going to divide by 16.8 pi, divide by 16.8 pi, x equals 1,476, divided by, notice I'm going to use parentheses here to make sure that pi is on the bottom as well. Sometimes students will make a mistake and put it on the top. Okay, and then you get 27.97. Okay, and that is our degree. Okay, last one here before we work on the other. We want to know what's the radius of circle N. So if we're working that with that formula, we know this is 45. So 45 over 360 equals the arc length, 1.57 over. Okay, so if you think the only way we can find radius is if we list out circumference, that's the only way we have an unknown variable to solve for. So we're going to look for r. All right, so cross multiply again, 360 times 1.57 gives you 565.2, which equals 90, because 2 times 45 is 90, pi times the radius. Okay, we're going to divide by 90 pi to get r by itself. So we have 565.2 divided by, parentheses, 90 pi, or 90 times 3.14, right? And so this would give you r equals about 2. We'll just say about 2. Okay? Which, I'm just curious, if you multiply this by 3.14, it's already rounding. See, if you use 3.14, it'd be 2. Okay? Because they rounded a little bit earlier. Okay. The region below is bound by circular areas. Find the perimeter. All right, so what it wants to know is perimeters, just like we talked about before, it is the distance around the outside. So it's not an easy shape to find the distance for, but since we know how to find circles, we can look at this in a different way. Okay, so if I'm looking at it, I'm saying, okay, well, I have this circle, and I have this circle. And since I have 2 of them, but I'm only looking for like this half of this circumference, I basically have circumference 1 is the purple put together since they have the same radius, is 2 times pi times 8. So circumference 1 is 16 pi. Okay, and that would be the 2 put together. Okay, now if I'm looking here, I have this one. Okay, well, that would be another circle that's very similar, only now it's only a half. So we have circumference 2 is half of that, of times 2 pi times 8. So circumference 2 is 8 pi, because half of 2 is just 1, so 1 times 8 is 8. All right, and then my last one I'm looking for, of course, is this outside perimeter. Okay, well, I have to look at it like, okay, here's a semicircle, and this is 8, 8, and 8, so that means my diameter is 8 times 3, which is 24, so my radius is 12. Okay, so the circumference here is, again, since it's a semicircle, it's half of my circumference, times 2 times pi times my radius, which is 12. So half of 2 is just 1, so circumference 3 is 12 pi. Okay, notice I haven't done any rounding because now at this point, I have all 3, I can just combine them. I have 16, 8, and 12. So 8 and 12 gives me 20. So 20 plus 16 is 36 pi. So that's my total circumference, or otherwise known as 36 times 3.14. Circumference is about 113.04. Okay, so that's how you go through a perimeter problem, and then these are obviously how you can solve for circumference, how you can solve for the angle, the central angle, and then how you can solve for radius, all different examples. So there's an exit ticket, very similar. Okay, I want you to go ahead and give this one a try. Let me know if you have any questions. Submit it into Canvas when you're done. Good luck.